Geometric sequences, example 4. Note, m over or, comma m or, comma dot 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 are three consecutive terms of a geometric sequence, where m over or is equal to the first term and or is equal to the common ratio. Now in your textbook, it doesn't use m, it uses a, but I think this is a little bit confusing because if you have a over or, comma a or, we're used to seeing the a as the first term, but in this case, the a would be the second term. So I've replaced a with m. So m over or, comma m or are three consecutive terms of a geometric sequence where m divided by or, divided by the common ratio, is equal to the first term and or is equal to the common ratio. Example, if m is equal to 10 and or is equal to 2, then the sequence is, so it's going to be m over or, which is 10 over 2, comma m, so comma 10, comma m times or, so comma 10 times 2, dot dot dot. And 10 divided by 2 is 5, 10 just stays as 10, and 10 multiplied by 2 is 20, dot dot dot. So this particular geometric sequence is 5, comma 10, comma 20. And what's happening each time is each term is being multiplied by 2. So let's say again we have m over or, comma m or, comma dot 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 being the first three terms of a sequence. And they don't have to be the first three now, they just have to be consecutive, but typically we tend to use them with the first three terms, but they could be the 7th, 8th and 9th term, for example, or the 5th, 6th and 7th term, for example. So long as they're consecutive. So multiplying these terms, so multiplying them all together, we get m over or times m or. So we're just going to multiply them all together. So I'm just going to make m become m over 1 and m or become m or over 1, just so that they're fractions, so that we're multiplying just three fractions. And then top by top, so m by m or is m cubed or. And then or by 1 is or. So bottom by bottom is just or. So if you multiply the three terms, you end up getting m cubed or over or. The or's will cancel and you're left with m cubed over 1, which is just m cubed. So m cubed, i.e. we cube the middle term. So this is a really handy rule that you can use to work out some of these geometric sequences questions. So this is just kind of the proof behind it or explaining why. But it's just really handy to learn off that if you cube the middle term, that you end up getting what the three original terms multiplied together would equal to. So remember, we started off with the three consecutive terms. When we multiplied them out and simplified, we got m cubed. So a quicker way of doing that is just literally to take the middle term, and that's why I've replaced the a with m, so m representing the middle term. You just cube that middle term and you end up getting what the three terms together would have been multiplied by. So it's just a much quicker way of doing it. So let's have a look at an example with some numbers. So let's say we have 2, 6 and 18, the first three terms of a geometric sequence. Again, they don't have to be the first three terms so long as they're consecutive. So they're three terms of a geometric sequence. Multiplying them, so 2 by 6 by 18 is 216. And if what we've just proven is true, then cubing the 6 should also give 216 because 6 is the middle term. And it does. So it works out. Let's take another example. Let's say we have 1 comma a quarter comma 1 over 16. So again, we have a geometric sequence. Multiplying the three consecutive terms gives us 1 over 64. So if we cube the quarter, we should also get 1 over 64 if this rule is true. And it is. So we get 1 over 64 when we cube a quarter, because a quarter was the middle term. So the rule is the product, which means multiply, of 3 consecutive terms of a geometric sequence is equal to the cube of the middle term. The cube of the middle term. I would suggest that you learn off this rule. Example 4. The product, which means multiply, the product of the first 3 terms of a geometric sequence, so we know if they're the first 3 terms, they are consecutive, is 216. And their sum is 21. So when they're added, the first 3 terms, we get 21. Given that the common ratio is less than 1, find the first 3 terms of the sequence. So again, product means multiply, sum means add. So we're going to let m over r, m, and m or be the first 3 terms of the sequence. And we know that when we multiply those terms, we get m cubed, the cube of the middle term. And it told us in the question that the product, which means multiply, of the first 3 terms is 216. So we can let m cubed be equal to 216 because the first 3 terms multiplied together are equal to 216. So we're going to get the cube root of 216 to solve for m, and we get 6. So that middle term is 6, the middle term of our sequence. We also know from the question that m over r plus m or is equal to 21. So we can replace each of those m's with 6. So we get 6 over r plus 6 r is equal to 21, because remember we worked out m to be equal to 6. So now we're just going to solve for r. So simplifying and bringing everything over to the left-hand side and simplifying, we get 6 over r plus 6r minus 15. We're going to multiply across by r to break up the fraction part. So 6 divided by r multiplied by r, the r's will cancel and you're left with 6. 6r multiplied by r is 6r squared, and minus 15 multiplied by r is minus 15r. And we just rearrange so that we have our r squared first, our r, our constant, and equal to 0. So we have 6r squared minus 15r plus 6 is equal to 0, and we can further simplify by dividing across by 3. So we're left with 2r squared minus 5r plus 2 is equal to 0. So going back to the question, we were asked to find the first 3 terms of the sequence, but we're going to have to find r, which we know is less than 1, to help us do that. So we need to solve for r now. So this is just the equation from the previous slide. So at this stage you can factorize or you can use the minus b formula. So factorizing, 2 multiplied by 2 is 4, so we get the factors of 4. So we choose 1 and 4 as our factor pair. This plus here tells us that these signs are going to be the same, and this minus tells us they're both minus. So we're choosing 1 and 4 because minus 1r minus 4r gives us minus 5r. So now we factorize the first 2 terms and then factorize the second 2 terms, and then our eggs should match. So we get r times 2r minus 1. And then we get minus 2 times 2r minus 1. So yes, our eggs match. So we've got the same thing in both sets of brackets. So we get r minus 2 times 2r minus 1 is equal to 0. And then letting each of the eggs or each of the sets of brackets equal to 0, we get r is equal to positive 2. Or we get 2r is equal to 1. So solving for r, we get r is equal to a half. Now going back to the question, it tells us that the common ratio is less than 1. So r must be a half because that's less than 1. We could have used the minus b formula otherwise, labeling a, b, and c. Writing out the formula, which is given to you in the formula book, no need to learn it off. Subbing into the formula and remembering to break the question down into 2 different parts, one with a plus and one with a minus. So we have 5 plus root 9 over 4 and 5 minus root 9 over 4, which again gives us 2 and a half. And again, from the question, we know that OR is less than 1, so OR must be a half. Now I know I have x there, that's just from my equation, my minus b formula. So I'm going to go back to OR now. So OR is equal to a half. So from our previous slide, we have OR is equal to 2 and OR is equal to a half. Again, we know that OR must be equal to a half because it has to be less than 1. So we have OR now, we need to figure out the first 3 terms of the sequence. So the first 3 terms again are m divided by OR, comma m multiplied by OR. So m over OR, m and m OR are our first 3 terms. We know m and we know OR. So we know m is equal to 6. We worked that out at the start of the question. So now we just sub OR and m into our 3 terms. So we get 6 divided by a half, comma 6 multiplied by a half. And we get 12, 6, and 3. So these are the first 3 terms of this geometric sequence. So 6 ended up being the middle term. We worked that out at the start. And then the common ratio is a half. So we're multiplying by a half each time.